The next three chapters are going to focus on the macronutrients that we have mentioned in the past: carbohydrates, fats, and proteins. We're going to start off by talking about carbohydrates. Section 5.1, we're going to identify the two major kinds of carbohydrates in the human diet, explain how plants make the carbohydrates, and identify the role of carbohydrates in the body. Carbohydrates include substances the cells of our body can use to make fuel. The whole reason that we like carbohydrates so much is because it is legitimately the fuel that we use to run the machine that is our body. Two major categories are going to be simple carbohydrates. These are going to include glucose, fructose, and galactose, as well as sucrose, maltose, and lactose. The most important sugar that we have is glucose. This is our body's primary fuel source. So when you think about it, that's going to be the one that we kind of focus on quite a bit when it comes to fuel for our body. Complex carbohydrates are going to be the starch and the fiber. We're going to talk about caloric sweeteners, things like high fructose corn syrup, table sugar, honey, maple syrup, and just like the name suggests, it's the ones that add calories to our diet. Now, ultimately, the examples that I've given you are the ones that kind of add extra calories to our diet. They're the ones that are added to, especially high fructose corn syrup, our cereals and things like that. A lot of our carbs come from plants. So how do they do this? The plant itself is built to absorb sunlight. It's built to absorb carbon dioxide from the general atmosphere and get water from the ground. With these three components, the solar energy, the carbon dioxide, and the water, within itself, it has specific enzymes and processes that will turn these things into glucose, which is the sugar that we want, and oxygen, which is the air that we breathe. The glucose that these plants are taking up can be made into fiber, can be made into starch, and to other sugars that we like fructose that is found in oranges and apples and grapes. In your book, in your ebook, you've got a video called the photosynthesis summary that is available if you want to watch that and actually see how all of that works with animation. 5.2, simple carbohydrate sugars. We're going to list the three most important dietary monosaccharides for humans, identify the basic monosaccharide components of sucrose, maltose, and lactose, explain the difference between a nutritive versus a non-nutritive sweetener, and then we're going to list three nutritive and three non-nutritive sweeteners. So, the simplest sugars that we have are monosaccharides. Mono means one, saccharide means sugar. So you've got monosaccharide, a single sugar. It is the basic chemical unit for all carbohydrates, no matter which ones you're talking about. A disaccharide, di means two, saccharide means sugar, so a disaccharide is two simple sugars put together. So you've got two monosaccharides glued together. And both mono and disaccharides are what we consider as simple sugars. Now, again, you've got another video in your book, in your ebook, that you can watch called Carbohydrate Structure and Function. The monosaccharides. We've got glucose, we've got fructose, we've got galactose. These are the three primary monosaccharides that we talk about. And if you look over here, you've got glucose, you've got fructose, and you've got galactose. And you'll notice that, especially with fructose, the structure is very different. I've got 5 sides instead of 6 like I do with glucose and galactose. The weird thing about this is all three have the same basic atoms. So you've got 6 carbons, 12 hydrogens, and 6 oxygens for all three. The difference is how they're put together. If I gave the class 6 yellow Legos, 12 blue Legos, and 6 red Legos and said to build something, the chances of everybody building this exact same thing are probably pretty low. So keep that in mind. Now, with glucose, you can also call it dextrose or you can call it blood sugar. Sources include fruits and vegetables, especially berries, grapes, corn, and carrots. It is the most important monosaccharide that we have in the body. Why? It's our primary fuel source for our cells. Remember, our body, for all intents and purposes, is a machine that has to run. Just like your car has to run on gasoline, your body has to have its own fuel. And in our case, glucose is going to be the primary sugar that we like to use as our fuel. So what that means ultimately is a healthy body has to maintain our blood glucose levels very, very carefully. Fructose, which can also be called levulose or fruit sugar, sources fruit, honey, raw vegetables, especially cabbage, green beans, and asparagus. Fructose is the one that tastes sweet, especially when you compare it to glucose. And we can easily make fructose into high fructose corn syrup, which is what a lot of food manufacturers include in their products because it kind of gives us that sweet flavor that we all love. You'll find it in soda, you'll find it in sugary cereals. High fructose corn syrup is in candies, but it actually does come from fructose originally. Galactose. Galactose is kind of like it sounds, lactose. You've probably heard of lactose. Galactose is a component of lactose. It's one of the two parts of lactose. And really and truly, we don't find it in a lot of plant products. We do find it in dairy products. Lactating mothers who are breastfeeding their babies also have galactose in their breast milk. Now, the disaccharides are going to include maltose, sucrose, and lactose. Maltose, like I said, you got two saccharides, two sugars. You've got glucose and glucose being glued together to make maltose. You've got glucose and fructose glued together to make sucrose. And you've got galactose and glucose glued together to make lactose. So maltose is found in a few foods, but it's malt sugar. The best way I can think to describe the taste of maltose is kind of a burnt sugar. Whoppers, the malted milk ball candy, that's maltose. That's why they call them malted milk balls, is because they use maltose in those. Malted milkshakes will have maltose in them. Sucrose we're more familiar with because this is table sugar. This is the one that when you're at a restaurant you put in your tea. This is the one that we put on our cereal. Lactose is found in milk and milk products, of course, and it is milk sugar. It is a specific type of sugar that we find in milk products. Sucrose is the one, like I said, that is kind of the one we think of most as sugar. Natural sources are going to be honey, maple syrup, carrots, and pineapple. We tend to refine sugar, the white sugar that we have on our table, from sugar cane or sugar beets. Refining actually strips what small amounts of vitamins and minerals are available in sugar cane or sugar beets. If you're talking about non-processed sugars that you might want to use instead that might contain those vitamins and minerals, raw sugar would be one, turbinado would be another. Some brown sugars will, not all. Oh, and the origin of honey. So for all intents and purposes, honey is basically bee vomit. Sorry, don't mean to ruin it for you, but that's kind of what it is. And I just thought in your book that was funny that they mentioned that. When we compare our refined sugar with the natural sweeteners that everybody raves about, the benefits of using honey instead of sugar. When you look at what all of these have, yes, honey has vitamin C and calcium and niacin and potassium, iron, and zinc. Molasses has calcium and niacin and potassium, iron, and zinc. But in reality, the numbers of these vitamins and minerals that are available compared to the calories that you're consuming don't really make it that much of a benefit. It isn't that they are extremely nutritious. Do you get these things? Yes, but not in really high enough numbers to count for anything. And you can look at this in more detail. So nutritive sweeteners. By nutritive, what I mean is that it gives you calories. It's not a no-calorie sweetener. So nutritive sweeteners are substances that are sweetened and contribute energy to foods. With our mono and our disaccharides, we're talking about the standard 4 kcal per gram. A lot of products add sugars to make their products sweeter and more desired by customers. If I make it taste better, more people are going to buy it. I'm going to make more money. If the first or second ingredient in an ingredients list is a sugar, you can almost guarantee that it's got a high amount of sugar added. So some of the nutritive sweeteners that are in this table include agave syrup, brown sugar, coconut sugar, powdered sugar, corn sweeteners like high fructose corn syrup, date sugar, dextrose, fructose, etc. You can read those if you want to. The other type of nutritive sweetener we're going to mention are sugar alcohols. This is an alternative nutritive sweetener. Sorbitol, xylitol, mannitol, these are the kinds of sweeteners we're talking about. These are the sugar alcohols. While they still provide calories, it's half the amount that you get from our nutritive sweeteners. So we get 4 kcal per gram with nutritive sweeteners. With sugar alcohols, we're talking 2 kcal per gram. So it's not zero, but it is less. One of the reasons that this is because it is very poorly absorbed in the digestive tract, and in high enough amounts, this will cause diarrhea. So we replace the sucrose in sugar-free gum with sugar alcohols, in sugar-free mints with the sugar alcohols, and diabetic candies. And if you look at the package of diabetic candies, a lot of times it says don't have more than so many or you get diarrhea, and it's because of this. Something else that's kind of a bonus when using sugar alcohol instead of regular nutritive sweeteners is the fact that it actually doesn't cause tooth decay. It doesn't cause the detriment of having tooth decay when you're putting it on your teeth. Honey and Clostridium botulinum. So Clostridium botulinum is a bacteria that actually is present in honey, usually in, low enough amounts that for adults it's not that detrimental, but for babies it can be. That's why normally we don't give babies raw honey, because there is a very good chance that that will be there, and their immune systems haven't had time to develop yet. So yeah, don't give honey to babies. Looking at added sugars in foods. When you look at the amounts of added sugars, whether that is in teaspoons or in grams, we get a lot of added sugar in a lot of different things. The funniest part about this list to me is the one that has the least added amount of sugar is going to be the ice cream. Now, here's the thing to keep in mind. This is added sugar. It doesn't mean that sugar isn't naturally in it. For example, with ice cream, we do have lactose in the milk that we are using to make the ice cream. We're just adding extra sugar to that. So it's not like the ice cream didn't have sugar before we added it. I just want to make that distinction. Now, the non-nutritive sweeteners. Non-nutritive sweeteners can be called sugar replacement, sugar substitutes, artificial sweeteners. These are substances added to food that will sweeten it, but they provide either few to no kilocalories to your diet. Something else that we tend to call these are high intensity sweeteners, and the reason is because these items tend to be a lot sweeter than what sugar is. So when we look at our list down here, you'll see that we've got aspartame. This is NutraSweet or equal. It is 200 times sweeter than sugar, than table sugar is. So we don't necessarily need a lot of it to make a drink sweeter. Nearly 0 calories with this. Saccharin, which is going to be our sweet and low, our sugar twin, our NectaSweet, it's 200 to 700 times sweeter than regular sugar. And again, kilocalories, 0. I'm going to come down here to sucralose. Sucralose is 600 times sweeter than sugar, and this is Splenda. The reason that I want to mention Splenda is because Splenda is one of the only non-nutritive sweeteners that we can use in baking. Most of the others, when you heat them in an oven to make cookies or a cake or whatever, those are going to break down, and by the time that you get to the end of baking, it's not going to be there anymore, so you're not going to have that sweet flavor. But Splenda is something that doesn't, which is why it has become so popular to replace sugar with in specific recipes. The safety of non-nutritive sweeteners has been questioned by the public and some scientists for a lot of years. But really and truly, when it comes down to the numbers, there is not really significant numbers in a higher incidence of illness with non-nutritive sweeteners than there are with regular sweeteners. So it's not something that you can say, yes, scientists have shown. Not really. The FDA has actually gone as far as establishing acceptable daily intakes for certain non-nutritive sweeteners, which you can see here. Although why you would want to have 75 packets of aspartame or equal, I don't know. Phenylketonuria is a disease that people who have it cannot metabolize phenylalanine correctly. Phenylalanine is an amino acid, which is a building block for proteins. And for these people, unfortunately, I can't ingest that and break it down like it's supposed to be broken down. Instead, I make these toxic products that eventually go to my brain and can cause really severe brain damage if it builds up enough. So people with PKU can't ingest aspartame safely. That means I have to be aware if phenylalanine is in anything that I'm eating. Because of this and because of the damage that PKU does, the FDA now requires manufacturers to label the products that contain aspartame because aspartame is primarily made out of phenylalanine. So phenylalanine and aspartic acid. So if you look here, you'll notice that this Dr. Pepper has a label that says it has phenylalanine in it because it's a diet Dr. Pepper that uses aspartame as its sweetener. Complex carbohydrates. We're going to explain the difference between a simple sugar and a polysaccharide. So again, mono meant one, di meant two, poly means many. So now we've got many monosaccharides, a lot of monosaccharides. We're going to explain the difference between a starch and glycogen, and we're going to identify rich food sources of starch, soluble fiber, and insoluble fiber. Polysaccharides are called complex carbohydrates because you've got monosaccharides all bonded together in this long chain-like structure. They are used as energy storage in both plants and animals, but they can also function as structural components of plants for their stems and their leaves. Common dietary polysaccharides contain hundreds of glucose molecules, some of which are digestible while others aren't, and we're going to talk about that. So the two that we can digest, the two types that we can digest are going to be starch and glycogen. Starch is stored in the form of amylopectin in plants. It is found in seeds, in roots, and fleshy underground stems, aka tubers. This over here is starch, and as you can see, I've got these long branching chains of glucose molecules, okay? Rich sources of starch include bread and cereal products that are made from wheat, rice, barley, oats. Vegetables like corn, squash, beans, and peas also tend to have starch in them. And the tubers that I was talking about, those are going to be the potatoes, the yams, taro, cassava, and jicama. Okay, all of these are underground stems that we dig up and we can consume. Energy-wise, starch is still going to be 4 kcals per gram, just like any other carbohydrate, even if it is this complex sugar. Glycogen, unlike starch that comes from plants, glycogen is a storage molecule for our glucose in animals, including us. There are two major sites for the formation and storage of glycogen, our liver and our muscles. Now, this is glycogen, and again, you can see all of these branching chains of glucose. Here's the thing, though. Glycogen is not something that we can find in our diet. This is not going to be something that if I eat a steak, because muscle makes glycogen, that it'll be there. Unfortunately, as we kill the animal, the glycogen breaks down. We store glycogen for short periods of time as well, but it's like if I had pancakes for breakfast with a whole bunch of syrup, all of that extra sugar from the syrup would be turned, some of it would be turned into glycogen in my liver, but after a couple of hours, that glycogen would be broken down and I would use it as glucose to get through the rest of my day. Now, the other polysaccharide that we're going to mention is fiber. Fiber is a complex carbohydrate. Again, it's this chain of monosaccharides that are made exclusively in plants as structural components of leaves and stems. These are the girders in a building. They are not going to be something that the plant takes from to make energy. While humans can digest many carbohydrates, fiber is not one of them. Our digestive system cannot do anything with it. We create no enzymes that can break down fiber. The microbiota in our gut, however, can. And that's sometimes how we get gassy and things after we've had a bunch of plant food, because they are breaking it down, not us. We've got two types of fiber, soluble fiber and insoluble fiber. Soluble fiber, it's a form of insoluble fiber is a form of fiber that does not dissolve in water. Remember, soluble means to dissolve. The components are going to be cellulose and hemicellulose as well as lignin, but lignin is not a carbohydrate. It's actually a polymer of 3 types of alcohol. Just so you know, technically it is an insoluble fiber, but it's not going to be a carb. Physiological effects from our insoluble fiber. It's going to increase fecal bulk and speed fecal passage through our GI tract. It actually helps to make more mass in our feces, which means that it makes it easier for us to go to the bathroom. Where do we get cellulose and hemicellulose from? All plants, wheat, rye, brown rice, and vegetables. Now, lignin increases fecal bulk and may ease bowel movements. It may help us to more easily go to the bathroom. We're going to find this in whole grains and in wheat bran. Now, soluble, remember, dissolve. So this is a form of fiber that dissolves or swells in water. We've got pectins, gums, beta-glucans, mucilages, some hemicellulose. They delay stomach emptying, they slow glucose absorption, and they can lower blood cholesterol. All of this is beneficial. Delaying stomach emptying means that we stay full for longer. Slowing glucose absorption means we're not absorbing as much of the glucose and extra calories. It can lower our blood cholesterol levels. Cholesterol can be bad for our health, so doing that is always beneficial. Where do we find these? In apples and bananas and citrus fruit and carrots and oats and barley, psyllium seeds, beans, and thickeners usually added to foods. So, fiber content in our food. When carbohydrate-rich food is refined, we already know this, we strip out a lot of that natural fiber content. A lot of the fiber that could be beneficial to our diet, to our health, is taken out. Depending on the refinement, fiber content can vary very widely. There we go. So, for example, if I've got an unpeeled apple, just a 6-ounce apple, I've got 4.4 grams of fiber. If, however, we process it and make it into apple sauce and take that skin off, then we've only got about 2 grams of fiber. So again, same amount, 6 ounces, 6 ounces. When we're talking about apple juice, again, 6 ounces, it's just fluid ounces in this case. Now we're talking about 0.4 grams of fiber. So you can see as we process this, we keep getting lower and lower and lower with our fiber content. When we look at the fiber content for a lot of foods, split peas are kind of our highest amount of fiber, 6.3 grams in 1 cup of split peas. Black beans that are cooked, you got about 15 grams. Oat bran raw is going to be about 14.5. As we come over here, barley, is about 3, peanuts about 2.7. By the time that we're getting down to romaine lettuce and iceberg lettuce, that amount of fiber has gone down very significantly. When we talk about white bread, look at that. Remember, I've said refining these things like into refined flour, that takes a lot of this out. Okay? Sorry. So, 5.4, learning outcomes. What happens to the carbohydrates once they're in the body? We're going to describe the major steps involved in digesting and absorbing starches and sugars, explain how the body regulates blood glucose, and explain what happens when cells do not have glucose to use for energy. Carbohydrate digestion, if we're going to follow it through the body. In the mouth, we have something called salivary amylase. It is a starch enzyme. Anything with amylase on it automatically means it's a starch enzyme. It's going to digest some starch, okay? Once we get to the stomach, though, that salivary amylase hits the acid in the stomach and it destroys it. So since it can't work anymore, there's no carbohydrate digestion in the stomach. When we hit the small intestine, this is the main site for our carbohydrate digestion as well as our absorption. Enzymes from the pancreas are going to be pancreatic amylase. Remember, amylase is a starch enzyme. So any starch that was left over from the mouth is now going to be digested by the pancreatic amylase, and it's going to turn it into maltose. Now, along the lining of our intestine, we also have enzymes. We've got maltase, sucrase, and lactase. Remember, anything ending in ase is going to be an enzyme. So maltase is the enzyme that digests maltose. Sucrase is the enzyme that digests sucrose. Lactase is the enzyme that digests lactose. So maltase is going to break this maltose down into 2 glucose molecules, because we know maltose is 2 glucose glued together. Sucrase is going to break down sucrose into the fructose and the glucose, and lactose should break it down to galactose and glucose. So we're taking our disaccharides and we're breaking them down into monosaccharides. Once we get done with all that digestion, the products of the digestion, so our fructose, our glucose, our galactose, are going to enter the absorptive cells, then enter the capillaries, and they're transported by the hepatic portal vein, hepatic means liver, to the liver. So the hepatic portal, the liver doorway vein, is going to transport everything to the liver. The liver receives the absorbed glucose, fructose, and galactose. If we did have soluble fiber, it will be fermented in the large intestine. In other words, we can't do anything with it, but the bacteria there can, so they might ferment it, break it down for themselves. In the rectum, we have very little carbohydrate that's getting out. We want to keep, as a functioning machine, we want to keep as much fuel as we can. So most of what we're getting rid of in our fecal material is going to be undigested fiber and waste products, basically. So again, if you want to look at this in figure form, the mouth, you've got some starch broken down to maltose by salivary amylase. The stomach, you've got the activity of salivary amylase stopping because of the acidic environment. In the small intestine, an amylase secreted by the pancreas pancreatic amylase starts breaking down whatever starch was left over into maltose. Maltase digests maltose into 2 glucose molecules. Sucrase digests sucrose into glucose and fructose. Lactase breaks down lactose into glucose and galactose. In the liver, glucose, fructose, galactose are absorbed by the intestinal cells and transported to the liver by the hepatic portal vein. The liver converts fructose and galactose into glucose. Why? Because glucose is our primary fuel source. Yes, I've got all the components. Remember, I said they're built with the exact same pieces. All I have to do is kind of switch them around a little, and then I've got glucose, which is the one that I want. In the large intestine, I've got some soluble fiber and other undigested carbs that are fermented by bacteria in the large intestine. Again, this is kind of how we get gas sometimes. And then the partially fermented soluble fiber and undigested insoluble fiber contributes to the bulk of our fecal material.